review safety statistic, as everybody knows, right, that the safety factors, which is causal factors. There are so many events that are associated with safety factors. The events that are associated with or influence fatality rates is a safety indicator, which is measurable safety factor. The probability of an accident is significantly higher during takeoff or landing than any other phase of flights. As you know, the fact, as I mentioned to you the other class the other day, that based on the percentages of accident over the years, accident is significantly higher during takeoff or landing. Now, risk is also a good indicator of probability of death due to traveling, but commercial aviation fatality rates are poor indicators of short-term risk changes. This is a fact that you do not get commercial aviation fatalities every day. Okay, so the accident exceed fatalities in numbers. They are still quite small. Accident can vary significantly from one year to the next. Hence, accident rates are poor indicators of short-term estimates of risk trend. Now, for the safety analysis, exposure data is used in transportation accident or fatality rates. So what do you mean by exposure data? Exposure data, they are information they are information that indicates the amount of opportunity for an event to occur, and is used as a denominator of rates, such as fatalities per passenger departure or electrical system failures per aircraft per hour. The passenger miles most appropriate when one is comparing air transportation with other modes of transportation. They allow generalized broad-based system comparison. So if you want to compare accidents by using passenger miles for the aviation, this is not appropriate. The aviation accident can vary greatly, hence the classification of accident as major, injury, or damage, or more popular with the insurance as hull loss and non-hull loss. Okay. This will give you a good overview based on the percentages looking at this chart. You can see based on the accident and onboard fatalities by phase of flight, okay, which is the source is coming from Boeing Statistical Summary June 2002. Looking at the accident and fatalities, you can see the aircraft is taxiing, doing loading or parking, on the average about 6% for accidents, 0% of fatalities. During takeoff and initial climb, the combination of takeoff and initial climb will be about 17% of accidents, and 6 plus 13, 19% of fatalities. During climb, if you look at the graph over here, it's about 9% accident, but because of that, the fatality is 24%. During cruise, literally the aircraft is cruising, chances of accident is slightly lower than if you were to compare during takeoff and initial climb. So 6% for the fatalities, and then descent another 5%, another initial approach 5%, where fatalities between descent and initial approach, if you were to combine together, about 30%. That is also considered quite high. For the final approach and landing, you will have almost 54% of accident, and fatalities about 22%. Okay. This is also another graph indicating the fatalities by accident categories. So, all these figures are from 1992 to 2001 figures. The accident by primary cause or primary causes, we look at here, flight crew. It's about 60% of accidents are basically were due to flight crew. And airplane, 40%, weather, 10%, miscellaneous, 5, maintenance, 3, airport or ATC also 3. So total with known causes is 149. Unknown or waiting report at that point of time, 2002, is 61, so total 210. So human factor is clearly and consistently the most frequent cause of accident and accident in the airline industry. So total contribution total contribution of human error to aviation incident and accident can range as high as 82 millions. The next will be, it's a very interesting topic. The accident causes and types. There are so many models that one can use in order to describe about the accident or the cause of the accident. We are looking at a model. So the purpose of the accident investigation is to uncover pervasive, unrecognized causal factors of accident. The goal is to help prevent similar accidents from occurring in the future and to recommend control measures. 2 is to conduct a preemptive strike on the very first accident to prevent it from occurring by addressing the root cause of the accident. Incident and accident provide after the fact that safety was inadequate. What do you mean by after the fact? So after the fact, basically you only know it only after it happened. So accident modeling assists with the understanding how accident happened so that measures can be taken to prevent potential hazards from materializing. Accident modeling helps us to understand the nature of accident. These are the accident model. One is to help explain the relationship between hazard and accident. Assist with understanding and explain reality. Aid in visualizing things that cannot be directly observed. We must must approximate conditions that exist in reality to be useful. First, let us have a look at the first model in aircraft accident investigation. The first one would be the Office of Technology and Assessment Model, OTA. The OTA model divides its safety indicators into 3 categories. One is primary safety factors, secondary safety factors, and tertiary safety factors. Primary safety factors are correlated with causal factors, such as personnel, which is what? Pilots, controllers, and their capabilities. Air traffic environment, aircraft capabilities, weather, unpredictable acts. Secondary safety factors are the one that consists of FAA operation, commercial aviation operation, and commercial aviation manufacturers that influence the primary factors, such as what? The airline operating, maintenance, and personnel training practices, federal air traffic control management practices, the aviation manufacturer design and production practices. The tertiary safety factors, these are federal policies and commercial aviation industry policies. Federal regulatory policy influences industry policy and operating practices. Industry philosophy and policy differ among airlines and dictate operating decisions. Tertiary factors reflect the values of a society and its economic philosophy. Example, deregulation. FAA defines an operational error as what? It is an occurrence attributable to an element of air traffic control system that result in less than applicable separation minima between two or more aircraft, or between an aircraft and a terrain or obstacles, as required by FAA handbook. An operational deviation is an occurrence where applicable separation minima were maintained, but loss in separation minima existed between an aircraft and protected airspace. An aircraft penetrated airspace that was delegated to another aircraft without prior approval. A pilot deviation is the action of a pilot that results in the violation of a federal aviation regulation tolerance. Next, we go on the 5M model. What are the 5M models? It consists of man, machine, medium, mission, and management, which present a valuable model for examining the nature of activity. The circles, which I will show you in a minute, intertwine, a means of checklist for fact-finding and analysis to ensure that all factors are considered. Now, all 5 factors are closely interrelated with management. With management, it plays a predominant role with mission, serve as a target or objective to emphasize. Initially introduced with 3M, which is man, machine, and medium, terminology by T.P. Wright of Cornell of U 1934. The 4th M, which is management, was introduced at USC in 1965. The 5th M, mission factor, introduced by E.A. Jerome in 1932 at military oriented. These are the 5M model. When we look at the bigger circle, which is the management, where under it we have man, we have machine, we have mission, and media. All these are interrelated to each other. And what is man? It includes all human involvement in aviation, flight crew, ATC, meteorologist, aircraft designer, instruction, maintenance, operation, and management. Very little study of man or human factor was conducted, although he or she learned something on mechanical aspects of the aircraft. The hazards of the weather, operating environment, etc., but not on his or her behavior or limitation, vulnerability, and motivation. These are all for the study of man. Now, due to lack of study of human factors, over the years, number of accidents caused by machine has declined. Those caused by men have risen proportionately. Consensus has now emerged that accident prevention activities should be mainly directed towards the human, to study the why of a person's action or inaction. People are reluctant to admit to their limitation, loss of faith among peers, self-incrimination, fear of job loss, consideration of blame and liability. It necessitated to probe beyond human failures. Was the individual physically and mentally capable of responding properly? Or did the failure derive from a self-induced state such as fatigue or alcohol intoxication? Earlier, most of the blame on accident directed towards pilot, or what we call it pilot error. The use of common question as to what happened, but now the investigation team would use more why happened, which would include all those human that handles the aircraft. What about the machine? History pointed out to the hazard found in the design, manufacture, or maintenance of aircraft, despite aviation technology has made substantial advances. A number of accidents can be traced to errors in the conceptual, design, and development phase. Fail-safe features and redundancy in critical components